All right, today we'll be talking about the command called DD. You know, it's called device dump or device copy, and it has a bunch of friends that go with it. Okay, and this particular command is used to do all sorts of things. You use it for forensics, you use it for backup and restore. I use it when I was mastering the lab here. The way the BIOS was set up, it would not boot from the M2 drive because it's legacy BIOS, not GPT. And I didn't want to change the BIOS settings and introduce more errors. So what I ended up having to do was create a DD of the boot disk and then just basically copy it to the M2 drive, reboot the box, swap the BIOS, no more problems. And now all these machines are booting from the M2 drive, and the secondary drive is an SSD, and the tertiary drive is an old spinner. So all that, and you can automate a lot of this stuff, okay? But I'm going to give you a first, for instance. I have a pen drive. I found it somewhere. I don't know anything about this pen drive, okay? This could be an active virus. This could be any number of things. So what do I want to do with this thing? One, I want to make sure that it doesn't cause any damage to my current working system. And in your Linux box, you will have found out that when you plug in a drive, a pen drive or just about anything, it automatically acknowledges that. Put a note somewhere in your notes. How does that happen? How does Linux know of new devices? How does it know? Okay. The reason I'm asking you to do this is, here, let me zoom in a little bit so you can see that. So we're talking about the DD command, and then how does Linux know that when you put in a drive? Now, when you put in a drive in Windows, what happens? It automatically reads the drive and it says, hey, I can't read the drive. Do you want to format it? Or in Mac, does the same thing. Now, you can configure your machine so that does not happen. And you have to specifically mount your drive, okay? The subsystem that uses the automatic mount, it depends on what you're running on. Are you on FreeBSD? Are you on Alpine Linux? Are you on AIX? Are you on HPUX? Are you on Red Hat, Ubuntu? Pretty much the stuff you're familiar with. Red Hat, Ubuntu, SUSE, Mint, all those. It will automatically read them because you've got the GUI enabled. Okay. When the GUI is enabled, it will automatically do its best to figure out what you've plugged in and what it is, okay? Now, I'm going to show you a couple things that all kind of go into this category here. It used to be that this required a lot of headache to be able to do this. Now it's just one little command and you can change it. It's so nice. You know, the people, you know, hate system control for many reasons, but it does have its place. And this is one of the places where it's actually kind of nice is you have to do this as root. So I'm going to use this pound sign to let you know I'm running as root. And you type in system, CTL. Now, what I'm teaching you today is probably not anywhere in test out. Okay. The DD command is in test out. And there are a few questions about DD. But what I'm showing you is way beyond the scope of what test out brings to the table when it comes to understanding the depth of just one command out of the whole Unix suite of commands, okay? So this system control, and then I'm just going to use this. Everybody has seen this, right? I will go over that in a second. System control, and I believe it's, yes, this is it, set default. I just did this a couple weeks ago, so it's fairly fresh in my mind. Set default. And then you type in multi-user dash target or dot target. Okay. Now don't run this on your machine quite yet. Okay. Multi-user dot target. Yeah, dot there. System control set default multi-user target. Okay. Now, remember, I have this pen drive and I want to show you how we can find stuff out about it. This is one technique using standard DD commands that I learned at a security conference on how you can use DD to do forensics on a pen drive. It was pretty interesting. So I'm going to use part of that technique today. Okay. All right. So here we go. Off into the world of screen share. And let's see here. I'm going to go to screen 2, hit share. You should see my VM here. Okay. So here we go. All right. Now, I am not on pure hardware. So you are going to have to take some of this with a large grain of salt because I'm doing this in a virtualized arena. And if I knew for sure that this pen drive was truly infected, I would be doing it on pure hardware, not in a VM, because some of the viruses that and payloads actually infect VMs. You just put the drive in and your VM's infected. Okay, so what I'm looking at is not, it's, I know what's on the drive, so I know what my outcome is supposed to be. And hopefully it doesn't take 5.5 days to make a DD of it, okay? I found a smaller pen drive. All right, so here we go. All right, so first thing I have to do is I need to disable the ability for my machine to automatically connect to my my drive, okay? So what I can do is I do this, sudo system control YS set default, okay? Now if I hit enter here, it says too few arguments, okay? So it's not telling me what it is, okay? All right, so what I have to do is you just take this on faith here, multi-user dot target, that's it, okay? Boom, notice what it does. It changes a symbolic link in multi-user target for default target. Now watch what happens. sudo reboot. Hopefully this works. You know how you do live demos, you know, things always take a, you're going, wait a minute, what's going on? Okay, so it's looking, it's talking, it's setting, it's doing its FSCK. Oh, look, where's my graphical GUI? All gone. Oh no, no mouse, no nothing. Okay, now before I do anything, you guys need to help me remember some of this stuff. Notes, I need to make some notes. All right, so let me go see if I have my machine set up to work. Oh, good, I do. All right, so I'm going to go to my class here. And I'm using for notes, this is fun. You don't care. You probably won't ever care. But this is fun. This is what I do. I set up the Jupyter Notebook on my main box, because then it doesn't matter if I'm on Windows or Unix or Linux or Mac or Android or whatever. I can get to my box and I can actually go into my classes and I can actually take notes. So what I'm going to do is create, I'll do it a couple ways. I'm going to create a new file, new text file, and I'm going to call it 2022 02 28, right? Yeah, 28 underscore the name of the class underscore dd.txt. Okay. So 10. So now I'm going to type this in. Okay. Notes about DD. And I system CTL set default multi-user dash target. Now, when I get to the end of the class, I'll show you a shortcut to do this. Okay. And the nice thing about setting up the Jupyter Notebook is that when I hit file save here, I also have this ability to open a terminal on my machine that so I can actually go to, oops, and there's the file I just created. There it is. Okay. All right. So let me move this back off to another location and continue on. So I'm now at a single user target. Now I can log in as root, or I can log in as my standard user. And for the sake of argument and what we're doing today, I'm going to dance on the edge of brilliance and log in as root. And hopefully I don't destroy things. So we're going to have some fun. Okay. So notice that once my mouse is in focus and I click, I hit enter, I don't see a mouse. There is no mouse. You know what? I don't remember the root password, so I'm going to have to do this. Before I do anything, I'm going to reset it. This is how you do that. When you use the sudo command, su minus, this is the little trick that one of my students told me about. I told them in class, and then I talked to them years later about some of the stuff that they were doing. And he said, yeah, this little trick with the minus sign has really saved a lot of time. What this means is log in as that user, okay? Log in, initialize their bash RC, use their .bash aliases, log in as that user. And you will find that there are companies that really frown on this because basically what you're doing now is I am now root. For all intents and purposes, I am root, okay? So I'm going to change my password so I don't forget it. Okay, I can exit, log in as root. Ta-da, there it is, ID. Okay. Now, this is where things get a little bit tricky, is that I'm in a virtual arena, okay? And if I make my screen a little bit smaller so it looks a little more appropriate, I realize that this is a little hard to see because I have this problem in the classroom too, is it's a little tough to see because it is in this non-GUI way, I can't do much as far as changing stuff, okay? It's kind of stuck the way it is. So hopefully you can see the screen well enough, okay, that you can see what's going on. Now, when I am now taking my pen drive and I'm going to put it into the computer. Whoops, I just dropped the pen drive. Now let me stand on my head in my fetal position here, get the pen drive and plug it in. And it talks. What's it talking to? It's because I'm on Windows and VMware is running on Windows. The pen drive is being acknowledged by Windows to say, what do you want to do with it? And you can see on my screen, it says, what do you want to do? And I'm going to say, connect to virtual machine, okay? Now, if I do a DF, there's no mount point. Where's my drive? Guess what, folks? Nobody has taught you how to find your drive at this level yet. And I doubt Test Out has done that yet. They might have. I doubt it seriously. There are literally dozens of techniques to pull your kernel to find out if you have a drive installed, okay? Or plugged in a USB drive. And because I have multi-user target off or multi-user target on, my machine thinks it's a server in a computer room. Why would you need a GUI running on a database server? Okay, you don't. It just, so you do everything manually, okay? So I have all these snaps and Red Hat uses something called Flatpak. Please take note of this. I'm gonna put this in my notes sections too. Let me go back over here and put this in here. Snap and Flatpak. It's spelled flat, P-A-K. You can run snaps on Red Hat and you can run Flatpak on Ubuntu. It's a way to bundle software that doesn't require changing your base OS. It is the way of the future. This is really important. And I'm not sure how much is in Test Out. But this is really a big deal, okay? So how do I know where my drive is? Where is my drive? I have no idea. So let's do a few different ways to look at it. I can pull. Now, notice what happened down here. Can you see? Let's see. I think you can see the share screen with the mouse down here at the bottom. There it is. Okay. That's my camera. That's this here. Okay. So this is what I've actually plugged in. If I was on actual hardware, it would poll it. But since I'm not, I actually have to tell it to connect to this. Okay. It still doesn't show anything. Still no mount points. So you see B and you see bit blob and you see all that. So how do I find my drive? Well, it's a USB drive. I can do LS USB. And it says, oh, look what I got here. I know it's a ScanDisk Cruiser Blade. It's a 16 gigabyte because that's what it said on the little device. And it says bus 01 device 03. Okay, what does that mean? Well, that means my kernel has found it. Okay. Hey, I got a drive. Now, what is it? Is it A, B, C, D, F, Q, W? Well, this is where you type in D message. And I scroll down and look here. All this is doing is you plug in a drive and it says, I see you. That's it. It does not read anything from the drive. Okay. So you can use a virus infected USB, plug it into a Linux box that's installed on raw hardware, running a non-graphical interface, and it won't get infected. Okay. Unless it's really, 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 really clever and straight from Russia or China. Okay. But for the most part, the viruses that are prolific today require that you at least have to click and run on something. Okay. And as long as you don't do that, you're probably pretty safe. So you can see that it sees it as SDC. So my drive, A, B, and C, it sees my USB drive as C. So now let's take a look at actually what's in or how it's structured before I do anything with it. Okay. So let's do fdisk, and I'm just going to list it, dev SDC. I see there's one partition and it's 14 gigabytes and it's a Windows 5 FAT32. Now here's what you can do. This is part of what I wanted to show you. I'm going to show you two ways to do this. Take note. This is the kind of stuff that makes you get the big bucks. Okay. And I'm making notes in my other screen here. Okay. And then what will happen is okay. All right. Now, the stuff I'm teaching you is definitely out of test out scope, but this is the kind of stuff that I used on a daily basis as a Linux admin. Okay. And I'm still learning new stuff. And that's part of the reason I wanted to talk about this is there's some new things that have been added into the Linux kernel within, I don't know what version, but it wasn't there on version 2 of the kernel, but it is here on version 5 of the kernel. So somewhere in that time frame, less than 5-6 years, there's some new things that let you do things. Okay. So what I want to do is I want to create a copy of this drive to play with. So I don't, this is somebody from the police department gave me this drive, and now this drive is forensic evidence, and I have to figure out what's on it so I can report back to the court. Okay. Of course, it's bogus. I found it in the lab and I picked it up and I said, oh, I'll use this one. It's not, I don't even know. I looked at the drive, there's not much on it. So that's part of the reason I chose it. All right, here's how you take a full copy of the entire USB drive. Okay, you DD, let me click, change my focus. DD, input file equals dev SDC. Notice I did not put the partition. I'm saying use the entire drive, output file equals, and I'm just going to give it junk.img. Now, there are other ways to do this to speed it up, but I'm just going to take the default. And then I like putting sync at the end of it, because then I know it's done. Okay. This shouldn't take too terrible long, but it will take some time. Okay. So while that's grinding away, what DD is doing is, because this drive is not mounted, it is taking head sector 0, copying it to the image file, head sector 0. It is a bit for bit, low level copy. This is how you can back up an entire disk and save it as an image file and copy it to another disk. Disadvantage is it copies all the empty space too. Okay. There are ways to bypass and get rid of and not back up the zeros and all the empty space, but definitely caveat emptor. That works fine for data drives, not so much for boot drives. I've had not much success getting this to work in an elegant, seamless way where you're compressing the zeros and getting rid of it and then just copying to an image file. Because your boot drive has pieces of data splattered all over the drive. Deleted data, good data, bad data. It's just splattered all over the place. And DD is not that smart. There are other more elegant ways to do backups and restore. Use backup and restore. That's an actual Unix command that's been around as long as Unix has. There is tar, there's CPIO. There's actually software you can go buy to back up things, okay? But what a lot of people do in production is they mirror things. They mirror the drives that are mission critical, and then they stage it to secondary and tertiary storage. And then if they need to, they roll it to a tape drive. And you know, that's what Foster did, okay? So you can see that this is gonna take a while. This is why I chose a small drive of only 16 gigabyte, because it does take some time. But what I can do is, now that my mouse is interfaced, I can do Control-Alt-F2 and I can log in again, okay? And I can continue on my journey here of tinkering around and taking a look at things. So while that's grinding away, what I want to do is show you another way to do this. Now, I can actually run this at the same time, but it's going to slow everything down, so I won't do this. This is another way of actually copying information off a drive. It's not any faster, and it still copies a bunch of zeros, but I want to show it to you because it's not common knowledge. Okay. All right. You can use the cat command and say, go to my device, SDE, redirect it to junk2.image. This works too. Now, where this would not work. All right, let's do a DF. Notice my root partition is on B. So if I do F on there, and it sees I'm on SDV, right? If I do cat /dev SDB1 /junk3 image, this will work. However, there are files that are open because I'm on a hot kernel. So my image may or may not boot. Okay. So it's a way to pull data. Let's say you don't care about the boot kernel. You just want to look at the etc directory. You can use this technique on a hot machine to actually get all kinds of information off that machine. Okay. Now, I'm running this as root. If I'm running it as a standard user, I'm going to get all kinds of errors, but I'm still going to get a lot of data. Like I'll be able to look at a lot of things in Etsy, not everything. I'll be able to look at a lot of things in the dev directory, not everything, but it'll give me some information about the machine so I can actually do some forensics on it, and figure things out, okay? All right, but because it's not mounted, C1 is not mounted, I can actually, let's spell it right, junk, I'll call it junk 2. And before I do that, let's go back. So it's still running. I'm hitting Control Alt F1, Control Alt F2, Control Alt F3, and this is how you can bounce around on your Linux stuff, okay? All right. So this actually backs up the partition to an individual file, okay? And one of the things I want to show you is while my DD is grinding away, let me log in. There's this command. I want to show you a couple of them. Okay. Ooh, that's a little hard to see. Sorry about that. Let's look at this one. This is a command I've just learned about. This is one of the new commands that's been added to the kernel. Its primary purpose is to help you master CDs, but it also lets you do all kinds of interesting things, like using snaps and Flatpak and mounting an image to your home directory. You're going, what? What? I'm lost now. Watch. I'm going to log in as guest. No password. Where am I here? I want you to look at what is this? This is a chunk of disk that has been allocated, I believe, to about 10 gigabytes. And I initialize it as ETX4, and I mount it to the guest user. When you reboot the box, the home directory for the guest user disappears. It gets trashed and it gets rebuilt. Okay. Now there is the guest capability has been taken out of Ubuntu 18 and 20 because it's a huge security hole. Okay. If you're going to set up a machine that is truly a kiosk, you need to set it up as a kiosk. Creating a guest user is not terribly secure, okay? And this is for the lab, and I jury-rigged this to make it work for the lab. My most common problem is people set the password with the guest, and then they can't log in again. I just tell them to reboot, and then it trashes it and rebuilds it, and then there's no password, okay? But what am I doing here? Notice it says bitblob. What is bitblob? That's what I called it, okay? So let's go to root now. Whoops, let me try that again. I need to put my mouse in focus. All right. What we are talking about is a combination of LO step, write this down, LO setup, and the other one is mounting a loop back, okay? So these are the two things we're discussing here shortly, okay? So I'm going to log in as root again. And where did I put that? I think I put it in the cron tab. Cron tab -L. Yep, there it is. And it says setup JCL. Okay, so let's have then JCL. Oops, setup.jcl. So this is what it's doing. Okay. That's actually not it. That's not what's happening. Okay, this is something else. The actual commands that we need right here are make guest home. This is the actual steps that I'm using. Okay. Is GPM installed? It is not. Hold on a second. sudo. I don't need that. I am root. apt install GPM. Now I'm going to show you some stuff that you probably didn't know about. GPM is a way. Notice what happens to my mouse now. My mouse is now inside the GUI. Don't tell anybody. Okay. So let's go back to here. Oops, pardon me. What I have here is a shell script that makes my guest home. Runs from root at reboot, creates a temporary file system called blob, and I make the permissions on this thing global because it's only used for that. So what it does is it clears the old temp. It says if old temp exists, then remove it. I don't even unmount it. I just remove it. Okay. So, and then I create a new directory called guest temp home, change your mods, and I mount it as tempfs, 4 GB, bit blob, temp guest home. So then what ends up happening is I copy this guest rebuild into guest home. Basically what that's doing is if I go to my 3 here, whoops, 4, and I do ls minus lai, you can see all these little dot files. That's what I copy in, okay? So everything works. So your X Windows work, Mozilla works, and you don't get all these initialization screens saying, hey, would you like to do this? Would you like to do that? So what it's doing is when I first created this, I created a brand new account called guest, logged in, did a few things, saved everything as an image, and moved it off, okay? So then I create this bit blob thingy. Whoops. Click. To actually do this. It's mounting it. It says T for tempfs size. It's actually creating a legitimate file system. As you can see, bit blob, 4 gig, temp guest home. So when temp users log in, they don't write anything to disk. They just write to this temporary file and it goes away. Okay. So I'll include that in my notes here. Make guest home. That's what I call it. Okay. Let's go back to see if our DD is done. Ta-da! Our DD is done. Okay. Notice what it did. It copied all 16 gigabytes. Okay. So what I'm going to do now is simply remove the drive. I don't have to unmount it. I don't have to do anything. I can just yank the drive out. Okay. And let's see, should I do that? Yeah, I guess I could do that. Let's let this run. We'll let this run here. So basically as root on my first partition, I'm running this. And again, this takes time. Okay. Now, if I do my ls minus ltr, it shows me my junk image of 16 megabytes or gigabyte. Well, now, folks, that image is on my hard drive. I can now mount that image. Mount -o loop, and then you say, what's the image name? Junk.image. And guess what? I need a mount path. So where do I want to put it? So let's do that first. So change directory to MNT. I got some junky things in there. Let's put one in here called make dir junk. And then for the other one, we'll call it junk 2. So I'm making 2 directories. There they are. And there's my files. So let's go mount. Now this is in test up. Okay. Junk, image, and then where do you want to mount it? MNT junk. Oh no. Why does it give me an error? Oh no. Wrong file system type. Oh no. What do I do? This is where I use a little setup. And I forgot the flags. I'm gonna have to go bounce onto my box and remember the flags. Okay. So now why won't it mount? I have an image, but it won't mount it. Why is that? Well, when I put the drive in, remember how many partitions it had? It had a single partition. So if I say, how do I mount just the first partition of that image? That's the error I'm getting. I need to mount the first partition of this image, okay? So hold on a second while I go jump over to another machine and try to remember what I did. Pretty sure it was on this machine. Because I actually use some of this stuff to solve problems from one of the things I was working with. Okay? I was actually doing this to prep images to go between VMware and VirtualBox and KVM, and mounting an image makes it easy. Okay. Hold on a second. Let's see if I can find. It might be under my login. Yeah, let me try that. So I'm tapping away on my Jupyter Notebook terminal on my machine in my office. Let's see what we got here. Let's see if this works. Oops. Goofed. Yeah. Okay. Let's see that. Nope. Hold on a second. Oh, it's on my machine at home. So over there. Okay. So let me hop over to my machine at home. And what I'm doing now is I'm using some SSH tricks to hop into my machine at home that are outside the scope of this class. It's definitely part of a security class. Patience, isn't it? Isn't it great watching people type on another screen when you can't watch anything? There it is. That's what I was looking for. Found it. All right. What I need to do is use the LO step command, LO setup, I should say. The LO, which stands for loopback setup. And I need the following flags: part, scan. What partitions do I have? Okay. I need to find them. And then I need to show them. And then I need to tell it what the image is that I want to probe. And this is junk.img. And what happens? It says dev 22. And I go down. Do I see a dev 22? No, I don't. There's no dev 22. It's loop 22. But this is what I can do now. Mount, dev, loop 22, P1, partition 1 to MNT, jump. Whoops. No errors. There it is. Those are the files that are on the pen drive. But remember, my pen drive is not present in the machine. Okay. So what I just flew through was how to take an image of an existing drive, all the drive, probe it, and see how many partitions there are, and then mount the partition I'm interested in. What if you were using a GPT? Question 4, test out. How many partitions are available under old formatting of MS-DOS? You should all know that one. That's going to be on your test. Okay. You're allowed 4 primary partitions. That's it. How many are on GPT? I'm not going to tell you. I want you to go look it up, because again, that will be on the test. Okay. So how many primary partitions can you create on a volume that is initialized with GPT versus MS-DOS or DOS? Okay. Those questions will come up. Okay. Guaranteed. Okay. So now what do I have? Remember when I ran the first forensics on it, it said it was a Windows 95 disk LBA, which means it's got the trash can, the system enable thing. So I can actually look in there and see what's in there. Okay. All right. So let's see what these are. All right. So I can actually cat task 1.txt, right? Yeah, it's a DOC file. Let's see what happens. Let's see how this works. Task 1. There it is. Not much. Looks like it's a simple little thingy bomber for who knows what it's for. But let's do a hex dump on it. -C on task 1. Because yeah, it's just a text file. Okay, I get it. But let's take a look at this image file here, that PNG file. Let's do a hex dump on it. Okay. This is actually a very clever way to embed bad things. You embed bad things in an image file, and it will not change how the image displays, but you can actually hide stuff in an image that can actually be pieces of code that will slowly, as the person uses it, not so much on Linux though, but on Windows, if somebody opens an image, a consistent image from a particular website, it can actually download pieces of that image and then put it together to create an executable. Okay, so that's a little scary, isn't it? It's pretty advanced stuff. Okay, all right, so let's take a look at here and see what we got. Usually what you want to do is look at the very beginning. All right, so it says it's a PNG file. Okay, good enough. All right, so when the very beginning of the file is something other than what the extension is, you want to be wary. Okay, so we know that this is going to be a image file, but can I display it? Nope, I can't display it. Why? Well, it's an image file. Do I have X Windows running? No. Do I have a GUI running? No. So I can't display it, can I? So what do? Well, there's a bunch of ways we could do this. I could shove it into my Apache directory and display it on the web, but probably don't want to do that. Probably take that image and try to do a little more diagnosis on it and figure it out, okay? So this is now done. Going back to this one. So you can see, what's the size difference between junk image and junk 2? Not a whole lot. But junk 2, when I ran the command, is what? Just the partition. So I can use mount -O for loopback, and then say junk 2 to MNT junk 2. Let's just make a liar out of me. Haha. What, folks? It worked. There it is. So what I've shown you is two ways. You can use DD to capture everything about a disk, including all partitions. Then you need LO setup to probe those partitions and mount the one you want. Step 2. You know exactly what you want off the drive. You can simply use the cat command and redirect the partition you want. In my case, I chose 1 to the image. And then I just use mounting loopback. Okay. All that to get here so we can look at data on a disk drive. Now, here's the beauty of it. I can take that partition and copy it to another location on another machine and mount it and make it available to my users, like BitBlob that I used for temporary guest home, right? So I can actually create a chunk of disk, allocate it. People log in, they do their thing, they log off, and it saves a snapshot of everything they've done in a .image file. Following me? So when you log into Linux and you get your shell command, you play around in your shell, you get all these little dot commands that build up history and cruft. If you mounted a .image file as your home directory, you log off, it all goes away. This is what the concept of a live disk drive does. A live Kali, a live Debian, a live SUSE, a live Red Hat. You boot off the CD-ROM, you do anything you want to do, and you reboot, nothing is saved. Okay? You don't have to boot live to be able to do that. You can actually do, there's other techniques involved. Okay? So now what I've shown you is the LO setup command. That's new to me. I learned that just recently. Very useful. It makes mounting the individual partitions much easier because you can find them. You don't have to go through make part probe and poke things around and look for the beginning sector and the ending sector and trying to mount just that individual chunk of disk. Makes your life much easier. Okay. So in review, what did we do? We found a USB drive. No idea what's on it. We changed our machine to boot into a non-graphical format. And we push in our USB drive. We find it by using dmessage. Then we make copies of it. We did two ways to make copies. We used DD to get a copy of the entire disk, and then LO setup to probe to find what was available. And then I did a mount with dev loop 22 on the first partition, okay? Because it found those partitions. And if I do fdisk on loop 22, which will be kind of fun, let's see what I got there. I think that was F5 where I did it. Or did I? No, I did it back over here on, because my history is all different on each one of these. Yeah, it's in this one. So I can actually do this, fdisk. Knowing it's a formatted disk for old school DOS, I can use fdisk. If I knew it was a new one, I would say gdisk, okay? Fdisk, dev, loop 22. And I hit P for, M for menu. And I just want to print the partition table. So that's just P for print. Look right there. I have one partition and it's called P1, which I've already mounted, okay? Can I now make more partitions? Well, if I resize them, because that's the full size of my machine, so I can use tools like resize to FS and truncate and actually shrink this image down to its actual size, okay? And I was doing that. Let's see if I can remember. It's fraught with error. Yeah, it will work. So what I can do to shrink the image is that I can do this resize. I can't remember if it's mounted or unmounted. So I've currently got it mounted. So let's do this. Resize. I think it has to be resized. Or hold on a second. Resize. Now I'm going outside the scope of DD, but that's okay. It's all kind of in its category. I say minimum. Make it the minimum size. Junk. Image. That was the first one. That says no such file, can't do it. Let's try junk 2. It says I can't do that. Why? Well, they're mounted. So let's unmount. Whoops. Let's get in the right directory where it actually exists. Okay. All right. I was in the wrong directory. Look, so if I do ls here, see, that's where they are. I was trying to do the resize command in the wrong directory. Let's see what happens. It says invalid. It's because I'm trying to resize the entire drive, including partition. It doesn't know what to do. But if I do this for junk 2, it still gives me an error. Oh no, why are you doing this? Because they're mounted. So let's unmount them. Unmount, or U-mount. Now I can U-mount them two different ways. U-mount, I can actually give it the directory name that it's mounted to, or I can give it the device name. Device is busy. Okay, that makes sense. Dev loop 23. Target is busy. Okay, so let me pop into these other screens and just log out here. Log out of that one, that one, that one, and that one. Back to this one. Now I'm going to unmount it and unmount it. Whoops. Let's unmount junk. Okay. No longer mounted. They're in my directories. Let's see what happens. Let's see if I blow it up. Let's take junk 2, resize it. Oh no. DK. Junk to the image. These are the stuff I don't remember. Yeah, not gonna let me do it. Okay. Well, anyway, there's two ways to shrink your file system. This resize FS, and the other one is called truncate. Be careful with this one. I speak from experience. Truncate, well, take your image, and if you don't do it right, completely destroy your image, you get to do it all over again. Okay. So I'll leave that for, because since we are outside the scope of what I really want to talk about, is the idea is that you basically, this is a way to defrag it. So you take your image file, you get the partition you want, and you can shrink it down to the size that it actually is. Okay. There's other techniques of doing this. You can actually do this from inside FSCK, or excuse me, FDisk, and you can actually delete half part of the partition and just figure out where it is. And you can do that. But you've got to use a combination of the DD command to find out what the last sector is. Then you go into FDisk and you say, okay, my first partition is only up to this sector, and then the rest of it's zeros. So let's create a new partition. Okay. I've already overwhelmed you enough with what I just did. We can keep going, but I don't want you to forget everything. Okay. So I'm going to put this together in the notes, and then I'll put the notes on the screen, and when the video finishes, I'll put it up. And you'll notice that when I've been doing the notes on my Philips D website, I'm not doing any markdown. I'm just making it pretty simple, stupid looking type of thing. And let's see here. I want to go to 10 labs. And I'll show you what I'm talking about here. I'm sure most of you already seen it, right? You've been reading up your homework. You've been doing everything great. You're all awesome students, right? Yeah, of course you are. Notice here, it's just a bunch of text. Well, why do I do pure text like that? It's so easy to copy, paste, and play. Okay, that's why I do that. It makes it very easy for you to tinker with it. Now, will this work as is? I don't know. That's where you get to go find out if it does or not. Okay, so that's kind of what, but this does make it easy for adding to your own notes, because it's kind of like a ripoff of my bash history, and I put my bash history into my notes. So I can do that. I'll go over here. Now that I've logged off all the other sessions, let's do this. I'm going to exit. Now I'm going to log in again. Type in history. That's everything I did today. So let's run that into a file called j.txt and cat j.txt. There's all my files. And one of the things I can do now is take a copy of j.txt and put it into my my note. Okay, I don't want to do that quite yet because there's a lot of garbage in there. I'm going to clean it up before I do that. Okay. So, who would have thought I would have taken almost an hour and a half to talk about one basic technique using a couple, 3 different commands? That's the way it is with all of the world of Linux. You find a command, you do a man on it, you can find out there's another 3, 4, 6 hours of study on that one command. Okay. So it just takes time to learn that stuff. Okay. And I'm giving you some shortcuts. I'm giving you some things that will help you backfill your information for test out by jumping ahead and giving you something that's not directly related to what you're learning, but everything you're learning in the test out, you need to be able to do what I just did today. So what I'm trying to do is bring it back to what does it mean to me and why do I need to know? Now you know, okay? So how easy was this in a big scheme of things? 2 commands, maybe 3, and you can look at a drive that might be infected or look at a drive that has some information on it that needs to be court ready. Not that hard, but you now know how to do it. And by the end of the day, or at least by tomorrow morning, you'll have the notes on how to do it. You just have to remember where you put your notes. That's usually my problem. Oh yeah, I did that. Where did I put my note? Oh, it's easier just to go learn it again, and I'll find my notes later. I'll make some more notes. And eventually you don't need your notes because you've taken notes enough time. Okay. All right, folks. Let's see what the chat was saying. All right. Home server. Script is root. Yeah, you can't run scripts as root unless there's a couple ways around that. You can use a sticky bit. If you are, suppose you'd like to run other tasks while DD is running, how would you recommend doing that? Monitoring HTOP, for instance, as it's running. If the partition is not mounted and you're not directly activating it, it doesn't matter. You can do whatever else you want on your machine, okay? But if the partition is active, like I showed you how to take a cat of the boot drive, you want the drive to be as quiet as possible if you're trying to image a live drive, because you are going to get errors and it may not work. Yes, you can use this for encryption. You can actually encrypt either before or after the DD, okay? And a lot of encryption type of tools work at this subsystem layer, okay? You've got, for example, create a legitimate logical volume manager with multiple drives encrypted, then create .image files on it that are doubly encrypted, okay? That makes it really hard for somebody to figure it out. And then if you do it, 3 or 4 times, you encrypt the encryption, makes it virtually impossible for somebody to figure it out. It also means your machine is going to get slow because every layer of encryption you add slows things down, okay? But for static data that it might be really like HIPAA or payroll or whatever, you definitely want to keep some of that stuff encrypted, okay? You don't want people to find out, everybody else's salary just by looking at a printer queue, okay? That's now a thing. You can actually send an encrypted print stream to your printer. It only took them 40 years to figure that out. Okay. That was one of the biggest attack exploits on finding information about companies is you just harvest their printer queues. All kinds of clear text. Okay. All right. So on that note, I'm kind of done. Any questions? You're willing to do this on your own machine now, right? Maybe not. Okay. All right. Let's see. After backup. Yeah, definitely. You definitely want to back up before you play with these techniques. Or set up a virtual machine and poke on it that way, because then there's no harm, no foul, no loss on using a virtual machine. Okay. And what I like to do is take an image of the machine I'm running on and run it as a virtual machine, then save it somewhere else, and then on another machine that may be running a different operating system. But if I've saved it as a .image, I can boot it as a VMware or a VirtualBox or a KVM. I have to do some conversions, but I can still boot it. And it's kind of nice to be able to boot the machine you're dependent on as a virtual machine somewhere else, because it makes it really easy to restore. Okay. So that's another little trick you get for free. All righty. Okay. All right. Yeah, you can run virtualization on a Raspberry Pi, but it's not fun because you can only run ARM type stuff on a Raspberry Pi. So it's hard to virtualize. And there's not enough horsepower really to. I've done it. I ran a TinyCore virtualization machine because there's a version of TinyCore that runs on the Raspberry Pi. So on the Raspberry Pi, I loaded Noobs, and then I loaded the KVM, and then I booted the TinyCore, and yeah, it all worked, but it was slow. And what am I running on this virtual machine? I'm using VMware and Ubuntu, and VMware is on Windows 10 right now. So it's the Windows 10 version of VMware. I could have done all this with VirtualBox. I just haven't converted my virtual machines from VMware to VirtualBox. Will it work? Yes. The problem is when you have a Windows virtual machine in VMware, you got to take a couple extra steps to make it work inside VirtualBox, but you can do it. Okay. It's kind of a pain. So I'm kind of waiting for my license to wear out on VMware. So I have to force myself to use VirtualBox all the time. Then I'll get pretty good at it. That's usually how it goes. And I've been using KVM since, forever. And the disadvantage with KVM is unless you load QEMU, QEMU, you can't run Windows. So if you're running straight KVM on a Linux box, you can only virtualize other Linux kernels. Okay. But if you load QEMU, you can actually load Windows and FreeBSD and some other things to your KVM desktop. Okay. Or KVM VirtualBox, whatever you want to call it. Okay. All right. I will assume your silence is consent. And I will take my notes and get them somewhat legible and get them ready. So on that note, I will stop the share. And any other going once, going twice? Okay, your silence is content. All right, I'm going to stop the recording.